Okay, I think we're on.
I think we are.
And let's see, let's check. All right. Yep, we got people here and more are arriving.
Oh, yeah.
This is going to be a little bit different, folks. You're going to be actually looking at us. We're going to be talking to you as opposed to going to a PowerPoint, because this is a new format that we haven't actually tried before, but it's kind of like Ask Us Anything session. And we received a whole list of questions from you. And Gerard and I went through them and looked at some ones that we felt we could answer.
Yeah, we cannot answer them all. So if we haven't answered yours, please be patient. We'll get to it at some point in time. But we're going to start trying these maybe in between each formal presentation webinar. We'll do one of these. And as you can tell by our dress code, these are less formal ones, right? I'm sporting my Boulder t-shirt from 2015. This is a company event for us. Richard and I and several of the guys from the office run it with us every year. And as you can tell, Richard is in our, what we're now referring to as our West Palm Beach office. Actually,
the winter.
Yeah,
the winter White House is how I refer to
it. The winter office. And folks, please make sure you send kudos to Richard for being a good son. He actually moved temporarily to West Palm Beach to look after his father-in-law, and so that is a very good thing to do. And I'm going to be drinking my mate here. I hope you folks are okay with that. I need hydration, and this is good for your health. So
you're covering the logo there.
No, oh yeah. By the way, how is this for shameless pandering?
Yeah, good.
I got this. I got this in Brazil.
Yeah, they make specialized mate cultivators.
Exactly right. No, I don't think they do, but that would be kind of cool. So, how about we get going? First of all, the first thing we're going to do is to go over the 3 points we made in the invite to you, which I suppose made you click and submit questions. And I believe a couple of questions are directly related to this. So we will quickly address those. We don't want to take too much time on this, and we want this to be an Ask Us Anything, and we will reply. For future reference, the more specific you can make the questions, the better we can answer. So as Richard is looking at the printout to get this going, as always, we would appreciate that those of you listening, go ahead and tell us where is that you're listening from. The names on the questions just reveal the international nature of our audience, and we're always very grateful for that. So please let us know where you're hailing from. And Richard, how about we go through I think 3 points we made in the invite, right? Was that the first one? Why batching can be better sometimes?
Oh, here we go. All right, these are the first chats. I wasn't sure if it was working, but yes, it is. Chicago, New Hampshire, New Jersey, Boston. But I suspect we have some foreign countries.
Oh yeah, Mexico coming in. Oh, St. Louis.
Yes, welcome.
Here in St. Louis a couple of weeks ago, visiting my granddaughter. Art in Denver, yeah. Come by the office. Okay, can be place.
Well.
But, love California. Okay. Going to LA to visit my nephew in March. I'm going to ride my motorcycle there.
Bulgaria. Wow.
Indeed, Italy.
Enrico.
Ciao.
Okay, so here's the first question. Let's get into it. Why batching is better sometimes, we said. Well, first let's define what we mean by batching. There are two kinds of batching. One is moving material in quantities of more than one. So we work on a quantity of make up a number 10, and none of those 10 move until we finished all 10. And then they move to whatever the next step or the next process is. That's one kind of batching. The other kind of batching is doing the same product over and over again. They may be flowing one at a time, but we're repeating the same product over and over and over again. So those are two very different kinds of scenarios. Now, back to the first one. Why would I ever build some quantity more than I actually need, well, you wouldn't normally. You would try to avoid that, but there are conditions under which you simply can't avoid it. And that primarily is the condition of long changeover times. So if you have a machine, you have a long changeover, you can't simply sit up and run 1 or 2 or even some random number. You have to run an optimum batch quantity. And so part of our mixed model line design training, goes through the methodology of how to set that batch quantity. How do you know what the right batch size is so it's not too big, not too small? The
As a matter of fact, we're beginning to deal with a brand new project that we're getting started pretty soon, where we suspect that this would be one of those, I'm going to say, rare occasions where we have an assembly line or assembly cell that has changeover. In this particular case, it's because of the nature of the parts that are heavy and awkward. And when there is changeover, and we actually tested this with simulation, when there is changeover, and the changeover is substantially longer than takt time, sometimes it's better to run a batch of one after another to overcome that changeover than running any model anytime based on customer demand. So sometimes it works better in that case. It's basically treating the assembly cell like a machine with changeover, which, by the way, we have a couple of questions on that too. So hopefully that answers it. And if you do have that situation, make sure that you do check your mixed model cell design or line design with simulation. We have questions on that too.
Okay, second question is how to stress the value stream or the assembly line or the production line without killing it. So the notion here is, you've probably seen this cartoon of a lake, and there's a boat, and underneath the surface of the water are the rocks. And so the analogy, the metaphor is you reduce the water and then the rocks are exposed. And so those rocks are problems, they get exposed, and then through the process of improvement, you eliminate those rocks, and then you're therefore able to lower the water a little bit more. So if you have too much waste, over resourced, et cetera, you could be covering up, hiding potential problems. So the idea of stressing a line would be to expose the problems or opportunities so they're apparent, and then doing something about it, and then going to the next level, reducing or stressing one more time, etc. So two things to say about that. Reducing inventory is the classic way of stressing the line, and that's something that Toyota will do if they notice they have very few shortages, or that chain is not pulled very often. The end-on light doesn't go on for part shortages. What they might ask themselves is, hey, do we have too much inventory here? Can we reduce it a little bit more and see what happens? Again, in a gradual fashion, so you're not killing yourself, but reducing a little bit. But there's another way to stress the line that we recommend, and that could be the case where you really have too many people, but you don't necessarily know it. You want to address that one, Gerard?
Absolutely. And that is, again, a topic that we teach in the class, and we work with our clients to adopt more and more. And lately, we've been very, very successful, very lucky in customers saying, yeah, we want to do this. 10 years ago, 15 years ago, we had a hard time convincing people to look into this technique, and that is flexing. Flexing means doing the work at more than one workstation, but this doesn't mean walking around looking for something to do. Flexing is based on demand signals, and as a person as an operator in a mixed model flow line, with flexing, you will work approximately 3/4 of your time at your primary workstation, and then based on a demand signal, either an empty in-process Kanban or empty workstation, you will move in the direction of the blockage, either downstream, next workstation, or upstream, prior workstation. What this is going to do is help you throttle the line, so you will be able to vary volume up and down, but productivity will increase for sure. And productivity, we refer to output per person. So that is one way we always recommend to test the line. Richard chose the word stress, which is perfectly okay, to test the line's capabilities. We've heard right here, one of our clients told us, which was unexpected. Oh yeah, they remember, Richard, the night shift, much more productive than the day shift. Why? They have fewer people, so they have to flex. They have no choice. They have to flex because you cannot change the line from morning to night, right?
Even that wasn't able to convince them to make changes to the first shift. I mean, they had the proof.
This is one of our success stories. After many years of thinking that flexing, and probably in part because we didn't communicate it right, I suppose. But I do remember the aha moment where we all looked at each other and go, "Oh, that's what you mean." And flexing became part of the private workshop we teach for them. So I think that. Yeah, go ahead.
There's something that I don't think even you, I don't think I shared this with you, but I'll share it with you and the audience. Last week or the week before last, our German partners in Munich signed almost like an R&D type contract with BMW, because BMW came to them and said, "Hey, we're seeing that this idea that you've been promoting of flexing, staffing strategies, etc., is really different from the Toyota production system approach that we've been pursuing, and we'd like to test it and like to know more about it." So that's being tested out right now in the automotive industry in Germany.
It makes sense as long as the volumes are not crazy. With very, very high volumes, it's very difficult to flex long distances on short takt times. But BMW is not a company that's making tons and tons of cars. They're making Camrys and Corollas. So yeah, absolutely, it makes a lot of sense.
Okay, last one. I think this will address a question that Ashok had. Ashok, if you're there, this one's for you. Why adding inventory can be the best and cheapest improvement? So the question from Ashok was, hey, isn't that really unlean, anti-lean? Adding inventory seems to be contrary to like the fundamental values of a lean approach to process management. So I think we probably need to say that reducing inventory can be a good thing. There are multiple reasons why you'd like to reduce inventory. There's not only the inventory itself, which is working capital cash, but there's also all the costs associated with having inventory, like paying for it and storing it and counting it and losing it and having it go obsolete, all of those issues. So we're not arguing with that point of view, but there are many cases where the flow of the product may benefit from having more inventory, and principally in the form of what we're calling in-process Kanbans. So if you don't have in-process Kanbans, or buffers, if you want to use that more generic term, then your line performance is probably degraded. And this is especially true in a mixed model environment where you have variability. So you have variability of people, normal human variability, but you have variability from one product to another. And if you don't have buffers, I can virtually guarantee that line performance is going to be less than it could be. And you can test that, you can verify that for yourself in a simulation environment or in the real world by just simply adding them. And the difference can sometimes be remarkable just by adding some more inventory to the system. So I don't think that's an unlean thing to say.
No, we even tested in class. Any of you folks that have come to class or will come to class, we do 3 simulations, right? We do 3. No, we do 4.
Yes, we do.
One simulation, we do the batch thing, then we do the flow thing, and we say, okay, those are easy ones, throwaway simulations, right? But we needed to set the stage. Then we do exactly the same simulation, same product, everything, but now we add IPKs, right? And the performance of the line goes up. And then the last day, we test exactly the same thing, exactly the same conditions with IPKs, and we remove a person and make him flex. And in some cases, we have seen the volume stay fixed, the output stay fixed, and the productivity go through the roof. So this point sort of appears to be in conflict with the prior point where we talked about not eliminating, but optimizing inventory. You don't want to have superfluous inventory, but on the other hand, and I heard myself, folks at Toyota say this, if you need to increase inventory temporarily to get the operation going smoothly, so be it. So don't be dogmatic about that. Now, don't throw inventory at the floor, call it an IPK and think it's good. We have seen that too. So inventory, IPKs in any form is waste, yes, but sometimes it will help you improve the performance of the line. So I will leave it up to you if you want to call that waste or not.
Yeah, it's the kind of waste I don't actually ever see going away. If you have a mixed model line with varying work content, there's no magic solution to this. This is the law of system dynamics.
Yeah, if you have a chronic imbalance, IPKs are pretty much mandatory if you have a chronic imbalance. Or what are you going to do? Get rid of the machine? No, you can't, right? Or buy another machine? If you have a chronic imbalance, having the tool of IPKs, additional inventory and time, is a very valid and efficient tool. All right.
With that, we've consumed 17 minutes, and we're going to try to keep this to an hour or less.
So 5
minutes.
5 minutes per question. So we selected, folks, you sent a ton of questions. So we selected a few that, for one thing, were very clear. And for another thing, I think they go to very important points on your daily lives in designing and managing lines. Okay, let me go to the first one from Lucia. Lucia, thank you for this question. And hello, has a value stream mapping, is value stream mapping useful in mixed model line design? If you told me you have to answer this in 5 words or less, I say no. However, is value stream completely useless? No. Value stream mapping is useful for the assessment portion that should precede your line design. When you get into the line design, you cannot design a line using value stream mapping. Here, what you will need to do, especially to figure out all the resources necessary, the balancing, and the future rules of sequencing, which you address on your question, is, or what you refer to on your question, is process flow diagrams and the mixed model process flow diagram. In this case, you're looking at all the potential flow paths that the product could follow. You could never address that in a value stream map unless you have a remarkably simple manufacturing line. Agree with that, Richard?
Yep. So what Lucia was asking is, if we have many different routings, how do you show those on a value stream map? Because some go here, some go there. It can be a very complicated railway system where you have a lot of spurs and et cetera. And as Gerard just answered, value stream mapping is really not the best tool. I mean, you could try to display that graphically, but it's not going to give you an idea of the relative volume, right, going through these different pathways. So really, I don't know of any other way to do it than kind of what we recommend, which is you have to create for every product an individual process flow diagram, or routing if you prefer that term, and then integrate them all into what's called a mixed model process flow diagram, and add volumes to those. So you can actually get a sense of where's the main flow, where's the main volume or the main line, and where are the lesser flows.
Yep.
Right. So I think that says it all. Yep. Okay. So we'll just go down the list.
Let me answer to Dianand. Dianand, I hope my answer here addresses exactly what you meant on your question. And this is something in which I have specific experience from projects. You want to read the question? Yeah. Hello, Richard. If you can help me with transactional process VSM, it would be great. And the question of transactional lines, meaning not a physical product, right? A receipt transaction, a credit application, right? This one has come up several times. I believe who was here, Mr. Mark White also asked on as a general question on that. This is something we have experience with, and I will tell you one story because you used the term VSM, and we just told you that you should not plan on using value stream mapping for line design, and we're very certain on that. But let me tell you one story on this one. We last year finished a project for a client, it's a hospital, that were in the process of selecting and implementing an ERP system. For those of you who are not familiar with hospitals, you cannot use ERP to run the hospital. The hospital runs on an electronic health record system. That's the primary system. And the ERP supports primarily from the materials point of view, and maybe they will do some HR, but primarily the materials point of view. So we help them implement their ERP system. This is a hospital corporation. Here in America, we refer to that as a hospital system that had 9 different hospitals. What we did for them, and it worked out really well, was to bring representatives from every hospital in the same room, and we actually did map, using the tool of value stream mapping, the transactions for every hospital. Okay, how do we receive inventory? Hospital 1, 2, 3, all the way through 9. We mapped them all, and then as a team, we identified the discrepancies, which were many. Not two hospitals receive material the same way, or put away the same way, or dispersed to company in the same way, or dispersed to sequences in the same way. Not 2 of them. And as a team, we developed a future state and a procedure. The future state doesn't tell you the how. The future state shows you the processes. Now we need to turn that and turn it into a specific procedure. When the pallet from Owens and Minors is dropped at the receiving dock, these are the steps we follow. So for them, value stream mapping, every single set of processes, but we limited that. We didn't go from door to door. We went from door to shelf, shelf to OR, right? OR to electronic health record. For them, using this technique worked very well. We have also used actual line design, and now I'm moving away from using VSM. VSM can be useful here. We actually used line design techniques for many line designs we did in the hearing aid industry, because there is probably 30% of the work in processing, in building your hearing aid is transactional. The next 2/3 is manufactured. The first third, all transactional, and we actually use the tools because of the many of the variability. We use the tools of mixed model line design for that. I think I exceeded my time. So, Richard, comment on that. You did some work also in banking for this, right, Richard? Yes.
We have, but we didn't really use VSM so much as we used just simple process flow diagramming, right? Flow charting as the kind of the visual tool. But we worked with one of the large banks, one of the top 5 banks, trying to improve the customer wait time. Basically, when you walk into a branch, you want to be able to get to the teller as quickly as possible. And interestingly enough, we used a flexing methodology there as well. Opening up a teller window when a certain visual signal would happen, not when the scheduling system told you needed a new teller, but when the queue of customers waiting got to a certain point, visually with literally a mark on the floor, that would be a signal for the supervisor or some other qualified person to open up a new teller window and keep that wait time within an acceptable amount of time.
Yeah,
but that was all flow charting.
In the hospital, the same thing. In the hospital, the same thing. Flexing was absolutely mandatory. You could never hope to have everybody you need to staff every workstation. Helen, I'd like to address your quick comment on this. And yes, I think I agree with your point, starting at the point closest to the customer. Yeah, I would agree with your point there. And sometimes that is how, most of the times, that is how we design lines. We start at the point closest to the customer to make sure that the set of processes, the value stream, the line in manufacturing, it can deliver in a reliable manner, and then we start solving the problems that arise from there. So I think we can move on to the next one. The next one, Michael, thank you for your question here. And we really don't have a recommendation.
Let's read the question. Let's read the question.
Oh, I'm sorry. If I remember correctly, in your previous webinar, you mentioned simulation software to help with line design and material flow. Do you have any comments of which software packages work better for mixed model simulation? So, two comments on that. Well, three comments on that. First, we don't recommend software because we don't like to sell software to you. So that's one thing. The next one is, I would say everyone we try works well with mixed model simulation, because the mixed model part of it, you design the line outside of the simulation software. All the calculations, the balancing happens outside, and you bring it into the simulation software and you feed it the mix. That's when you test mixed model. All right, so you do a static simulation outside of the system, then you bring it into the simulation software to do the actual dynamic test. Now, one recommendation we do have for this is whatever software package you pick, and I'll tell you, ProModel is good, Simulate is good. There are many, many good packages out there. Make sure that it does have an interface to bring data from a spreadsheet. Right, Richard?
Yes, and I know for a fact, I don't know about all of them, and there are probably dozens of simulation, packages out there. But we have worked with a few of them, and I know that they do have this capability. One is ProModel has I think it's called Process Simulator. It's an add-in to Visio, but it does have that capability in the full version, not in the free. They have a free version you can get, but in the full version. The other one is Simulate. And the reason this is important is you want to be able to simulate a specific sequence. So just random arrivals in your simulation model is not going to help you that much. So you need to be able to specify that. But I think just about any package should be able to have that. The biggest, it's not so much the software. The biggest, problem or challenge for the casual simulation user is the cost of it, because simulation software is not like Microsoft Word. These software companies, simulation software companies, are not selling millions of copies. Why? Because the need is not as high as the need for a word processor, for example, and also, the number of units they can amortize their R&D costs over is that much smaller. So I think what some of these companies discovered, thinking that they were going to penetrate the market by being a lower cost provider of the software, Simulate in particular introduced their first package, I don't know how, 15 years ago, at like $495. Right, we're going to be cheaper, and we're going to really penetrate the market. And they were disappointed, I think, in the results of the lower price, simply because the market wasn't big enough. So to make a long story short, these are, no matter which one you look at, they're not cheap. They tend to be in the multi-$1,000 range. And so if you're just kind of curious about simulation, it makes it kind of a problem, all right, to just kick the tires on these things. Now, as I said, ProModel has a free version, but it's fairly significantly limited, I would say. So,
and make sure you make the commitment, because there is no such thing as a part-time builder of simulation models, right? It just never get good at it. All right.
It's like being a part-time programmer, right? I'm a part-time C++ programmer. Well, chances are pretty good you're not really very good at it either, because you haven't put in your 10,000 hours. Right?
So
okay.
Let's go to the next one. I have a follow-up question. How can you reduce the changeover using SMED? And then what algorithm should I use for mixed model balancing? I think the first question can be answered in what, 20 words or less?
Yeah, or 4 words, 3 words, buy the book.
Yeah, exactly. Listen, and we tell this to our clients. We're happy if you want to engage us in a consulting project to help you with changeover reduction. Happy, right? But you don't need it. Buy the book, read the book, buy our book, buy somebody else's book. This changeover reduction program is not difficult to do. Just do it. The first time probably won't yield the results you expected. Do it again. This is not difficult stuff. Read the book and do it yourself. Now, you have money burning a hole in your pocket? Give us a call.
Albert, thank you very much. Albert says, can you recommend literature for reference or guidance to develop a mixed model line? Well, if we're talking about SMED, the easiest book I think we've used is Operator Guide to Quick Changeover. Yep. It's not our book, but it's a pretty well done, easy to read book. In terms of mixed model line, we do have a book called The Complete Guide to Mixed Model Line Design.
Yeah,
so you can find that on.
That's a very good book.
Yeah,
the writing is so smooth.
It's like champagne. Now it's available on Amazon or from flowpublishing.com, Albert. So we do have that. Yep, we can provide that.
And
the other part of the question, though, algorithm.
I think that question needs to be answered by replacing the word algorithm with process or procedure. And that is, what do you say, Richard? This is lesson 12 in the mixed model online workshop. And that is basically, no, it's 2 lessons. And basically it is balancing a set of processes, balancing a line using the balancing tools, right? So in class, you're going to go through elimination of waste, relocation of work, addition of resources, inventory and time, and finally sequencing. Those are the tools. They are in class, and since we cannot go over all of them, for anybody listening to this workshop, we'll give you a 50% discount on the class. We have this coming up as an offer here in just a minute. We'll show you how to do that. But there is a methodology that you need to follow, and it's in a certain sequence, a certain order, and it's not a one-time deal either. It's an iterative process, and it's an important one. I mean, of all the aspects of developing a mixed model line, level loading or balancing that workflow is really critically important for high performance. Looks like Albert is on to us, Richard. Thanks for the shameless plug. Yeah, collect your $5 at the door. Thank you. All right. Okay. Next one, Scott. So Scott says, assuming a machine is a shared resource, how do you know you have balance between too large a batch to ease changeovers, reduce the changeovers, but add some inventory, and yet not too small a batch, causing too many changeovers with less inventory and idle workstations? Okay, well, that's a good one. And we do have an answer for that one as well. And we have a methodology. Yeah, we don't have enough time here to answer it as a question. We do, no, we don't. But it's an hour-long lesson probably
in our online course.
Yeah.
And it's discussed in the book as well. It's the step-by-step process you need to follow. But there is a way of analyzing your run times, your available work time, your demand, right, for each of the items going through a machine, and coming up with an optimum batch size. And that's something you need to do. I mean, that's critically important. Gerard and I were just talking this morning. Some MRP systems may or may not, I don't really know, calculate that for you in some way or another, some algorithm, but many of them don't. And we were talking about a system we came across recently that has a field for batch size, that it's going to use. So when you have a demand for that part, it's going to tell you to run that batch size. But that's an input number. So that's coming from outside the MRP system. So you need to have some way of doing that analysis, right, and telling the system what the right batch size is.
And this is
excellent point.
What it's referring to is a modern APS system. This is not a Joe Orlicky vintage MRP system. This is a modern APS system, and it was purchased by our client on the premise that it would help with this, but that's going to be part of our project. So, and again, the process of the procedure is going to be, you have changeover on this machine. So first figure out that changeover, and you're going to have to calculate a weighted average changeover. You have no way around that. Then what you have to do is figure out how much time you have left for changeover. So you're going to take all the products multiplied by the daily demand, right? You're going to take all the products and multiply the daily demand by the runtime. That's going to give you the pure runtime, no changeover. Subtract that from the available minutes. That's going to give you the time to do changeovers. Divide that by the average changeover. That tells you how many model changes you can do. Compare that against the list of products. Chances are you're going to say, I can do 10 model changes, but I have 25 different products. From that point on, what you start doing, remember, line design is predicated on running every model every day. So then what you are going to start doing is decreasing the frequency, meaning increasing the batch size, and you're going to come up with an optimal batch size for each one. That's as far as we can go. Entire lesson in the class, and again, since we're selling you the class here, it's going to come with a discount, so you can take.
Yeah, so I popped it up on the screen here. So I think you should be able to see this. So 50% off. The code is batch. The discount code is batch. I think some of you are probably wondering what is the 50% off? What is that price? It's $200 and something. So
yeah,
we
made it very. Yeah, we made it very.
It's the same class that we teach at Toyota, just in an online version. So
yeah.
There you go.
Excellent. So, Mark, Mr. White, I think we addressed your question, and maybe we need to do a webinar just dedicated to administrative processes, or processes where the flow is not a physical product but a transaction. I hope we addressed some of your question here. And again, I would be very interested in understanding the transaction workplace better. So hopefully we addressed some of that. Do we have time for one more?
I think so. And let me just respond to a comment from Helen.
Okay.
Helen, get back to the issue of software. She said, if you work for a big company, you probably already have it. I think that's a true statement. Somewhere in the organization, right? Someone at some point in time has bought this, or part of a chain with good links to a university. They may have it. That's true also. However, that's not the main obstacle. It's not even getting a hold of the software. It's the learning curve. Knowing how to use it. Because I worked for a simulation software company for a few years, and I grew to appreciate the expertise, the depth of knowledge required to really use this correctly and really get good results. So you have two challenges. One is, where do I get access to the software? But the bigger challenge, much bigger challenge, I think, is the expertise, because the learning curve is not small. Unless you're a complete genius at this, and really can get up to speed faster than a normal human being, the learning curve is a little steep. It's easy to do simple models, right? And that's what they show you when they're trying to sell you the software, how easy it is to use. But when you actually get into real world challenges and you have to do coding, which you invariably have to do, then it becomes a lot harder. So,
yep. So when we teach simulation in class, and by the way, later this year we're going to start a new class. Is the advanced mixed model line design, and we used to teach a class just dedicated to simulation, and it was a little heavy. And we're going to include simulation into our advanced mixed model line design. And our goal is not to teach you how to build simulation models, but to be a good user of simulation models. And we believe that's very important. We have been able to really improve and polish line designs with an expert building the model and the rest of the team asking the right questions and obtaining the right information and improving the line design. And we have challenged ourselves with our own static line design, with a model saying, hey, maybe you calculated 6 stations, maybe with the 7th one it'll flow better. And you tested with different mixes. And I remember at one line we did change the number of workstations based on what the simulation model was telling us, and it was a big success. Renee, just to quickly address your question, we're big fans of Polka. However, we don't get to use it all that much. And I believe the main user of Polka here in our firm was Richard in a project that was unusually complex. Picture a landing gear from an aircraft. It can get only so many landings, and after so many landings, they remove it. They don't even ask, is it good, is it bad? They just remove it and send it to be refurbished. So picture taking a landing gear, which is heavy and has lots of parts, okay, and blow that thing up, disassemble it, and from there, it could go anywhere. Some parts have to be refurbished, some parts have to be replaced, some parts don't need to be touched, right? But it could go anywhere. Trying to balance that was a challenge, and Polka really did work for it.
Yeah, not only that, but many of the same parts had to come back together in the same assembly because they were serialized. So it wasn't a matter of, one becomes 300 and then the 300 can just go into stock and be pulled out to reassemble a new landing gear. No, the same pieces had to come back into the same landing gear, which was a challenge. Anyway, for those of you who are wondering what we're talking about, Polka is paired overlapping cards with authorization. It's a methodology for improving throughput, right? Reducing WIP in a machine-intensive environment. And it's documented in some detail in the book, Quick Response Manufacturing by Rajan Suri. Yeah, so great book, an easy read.
Very good job. In some detail, the book is this thick.
Yeah, it's like 600 pages, I think. So
in a lot of detail. Very well written book. We recommend it.
Yeah.
Don't try to read it at once.
Yeah, one sitting. In fact, it may be the kind of book you never actually read. You just look for the parts you need.
Exactly. It's a great reference book, and again, very well written. Dr. Suri did a great job on that book. We recommend that book should be part of your line design library. And to give you an idea, we don't even have time to teach Polka in class. All right.
Yeah. So, all right, can we do one more thing, Gerard, before we conclude? We're coming near the end here. We have one more question I think we want to get to from Basti.
Yep. We want to get to
but before that, I see Renee, very busy here, has another question. For high mix, low volume, can we apply the mixed model line design methodology? One of the things I wanted to comment on is if you're very high mix and low volume with a wide range of work content time. So I have a 1 hour product, I have a 10-hour product, I have a 5-hour product, and the volumes are extremely low. I may be only building this once a year. right, or a few times a year, I don't really have a good flow. I think what your question is, Renee, is how do we deal with that kind of environment? Aerospace is a typical example of that, where the work content can vary a lot and the volumes are very low, right? And we have to build them all. So can the mixed model methodology apply? Yes, but many times you'd be treating subgroups of those products as families and trying to build them, in that way, right? Taking similar products, similar work content, similar materials if you can, and building them as a family. If you can't even do that, then still the mixed model line design methodology would apply, but almost on a product by product basis. In other words, picture setting up a cell, you run that product, and then you change over and run a different product, and each one of those products would have been designed, right, and balanced, but to the product as opposed to a mix. But the methodology will still apply in any case. Mm-hmm, mm-hmm. So that very high mix low volume is can be a challenge, but can be done. What you want to avoid in a high mix low volume is single station build kind of environments, where you give, and this is common, right? But you give Johnny, Susie, a basket of parts and say, okay, go off and finish this job, right? And they go off to a workstation and they have all their tools and they finish up the work and they come back sometime later, undefined time later, and they finish the job. You want to avoid that because there are a lot of issues with that. There are productivity issues with doing it that way. There are quality issues doing it that way. So you want to have people building products as a team, right? As a group in general. Even if it's the same product, right? Even if you're focused on one single product, you still want to do it that way. Agree, Gerard?
Yeah, completely.
All right.
Shall we go to Vasti's question? Can you read that one?
Okay, ideas from us, I guess. How to keep lots unity. So how to keep lots together, I think, after assembly process like sewing, and ship it, with the constraint of lack of physical space to consolidate carton cases. So I think what Vasti's saying is we have products that we're building. It looks like a garment industry, and we'd like to ship in full boxes or full pallets, pallet quantities to a customer. So how do we keep that same customer's order or orders together, because we don't have a lot of room to stage at the end of the line? Yeah. If you had a lot of room, you just have a spot for each customer and you just keep on working until that spot fills up and then off it can go. But they're saying they can't do that. So what do we do? Well, I wish there was a magic wand, right?
No, there is no magic here, Vasti. You're going to end up paying the price. And the price there is going to be in changeover, because what we pictured here is a series of garment building processes, and say an order from Macy's came for Levi's 502s, different sizes, and Wrangler shirts, lumberjack Wrangler shirts, different sizes, followed by Under Armour hoodies, different sizes. And if you had similar products for Macy's and Harrods and say another and somebody else, another department store, you could set up all the department stores separately, right? If you have the space, and then build all the Levi's 502s for Macy's and Harrods and who else, Richard? Give me another department store. That's Fifth Avenue, and then all the Wrangler shirts for Department 1, Department 2, Department 3. Well, but if you don't have the space for that, then you're going to have to build for Macy's the Levi's 502s, followed by the Wranglers, followed by the Under Armours. And what happens there is that you're doing more changeovers. You're going to have to pay that price. So back to the question from I don't remember.
Vasti.
No, Lakshmana Prakash.
Very good.
Get good at changeover improvement. at changeover reduction. So read SMED and get good at that. That is our perception of the question you asked.
Yeah, and Phil suggests going vertical. Yeah, well, sure. If you've got the vertical storage space.
Yeah, going vertical. Get an order picker, right? I mean, or get an ASRS. Did not consider that option because some of those get to be a little expensive. We were just going simple with the pallets, the boxes on the floor. But yeah, going vertical is definitely a good idea, and Basti, you should consider that. Hopefully, we interpreted your question correctly and gave you a useful answer.
Okay, so it's maybe we come to a good stopping point. It's 12:51 on the East Coast, where I am. I'm in beautiful West Palm Beach, Florida, right now, in our southern office. Maybe we've come to a good stopping point.
So, folks, since a couple of times we mentioned our books in our classes, we want to be fair to you. So please use the 50% discount code and pass it around to your friends if you want. We won't check.
It works for other people as well.
Exactly.
So we'll plan on doing this again. I like this new format. We'll probably mix it up a little bit as opposed to picking a topic and going in depth, looking at a variety of questions from you. So I think we'll do this again in the future.
Yeah, maybe every other one, but we want to make sure that we also stay, on one topic and beat it up, so you can actually turn it into an actual tool for your toolbox. All right. Okay. So from beautiful Boulder, Colorado, where it is right now 10:52 in the morning. I think
temperature.
I'm sorry.
Temperature. Outside temperature
outside 41 degrees Fahrenheit. So 42 minus 10 plus it's 5.5 degrees Celsius outside.
Okay. All right. And today,
Richard, you're pixelating.
72 degrees outside here.
Damn you,
Fahrenheit. Yeah, which is what, 20?
Yeah, like 21, 22 Celsius. So I hope a typhoon comes your way. So folks, that's all we have for you. Please make sure you give us some feedback. If this format, you find it useful, we'll do it in the future. After all, we'll do these to spread the knowledge. Thank you all from beautiful Boulder, Colorado. Gerard, bid you farewell, and until next time.
Bye now.
Bye.